Good day, grade 10s. In this video lesson, I would like to discuss in more detail ionic bonds and metallic bonds. So, ionic bonds are formed, to just refresh your memory, when there is a transfer of electrons from metals to nonmetals. So the metals form cations and the nonmetals forms anions. And each of the ions would have a stable electron configuration. The extremely strong electrostatic forces between the ions keeps the ions in fixed positions in their crystal lattices, and it gives the substance a very high melting point. The properties characteristics of ionic substances are the following. They are non-conductors of electricity in the solid phase. They are extremely good electrolytes. So it means that they are good conductors of electricity in the molten state, or in solution. They are very hard, they are brittle. So they break along planes. If I can explain this, a diamond has a characteristic shape because when it is polished, it breaks along certain planes. Salt crystals will always be small little cubes, because if you take a big cube and you break it, it breaks into small little cubes, because they break along specific planes determined by the arrangement of the atoms in the lattice. Because of the very strong Coulomb or electrostatic forces between the ions, they have very high melting and boiling points. All these properties are explained by referring to the very strong Coulomb forces of attraction, or if you want to say electrostatic forces of attraction between the ions. And when like charged ions are forced to come alongside each other, these like charged ions will repel and the crystal will break. I would like to work through some examples of ionic compounds using Lewis structures. I'll start off with the simplest one, sodium chloride. Now, sodium is an element in group 1, and it's got 1 valence electron. Chlorine is an element in group 17, and it's got 7 valence electrons. Now I'm going to use these Lewis structures to show you what happens and how the bond forms. Now, because sodium is a metal, it is electropositive. And chlorine is a non-metal, so it is electronegative. It tends to form anions by taking in electrons, where the sodium atom is electropositive. It forms cations by giving electrons off. So the electron goes from sodium, it is transferred to chlorine. And the way we represent it is like that. The electron goes from sodium to chlorine, and then sodium would be a positively charged ion. And chlorine is drawn in square brackets like this, and all its electrons are shown like this, with that extra electron that comes from sodium, and it's got a negative charge on it. So this is the Lewis structure, the Lewis structure of sodium for sodium chloride. Let's go to the next level. What about potassium oxide? Now, potassium is also an element in group 1, so it's got 1 valence electron. Oxygen, an element in group 16, has, let me rather use these dots so that you can see where the electrons are coming from. The oxygen has 6 valence electrons. Righto, so sodium is electropositive, so it will give its electron to oxygen. But oxygen needs 2 electrons, so another potassium atom is required to give its electron to that oxygen there. Now we have 2 potassium ions and the oxygen ion. The potassiums are cations, the oxygen would be anions. And the oxygen received 2 electrons, so it's 2 negatively charged. Oh, by the way, we better write the sodium chloride's formula. We can see that 1 sodium joins to 1 chlorine in sodium chloride. Here we can see that there are 2 potassiums joining to 1 oxygen in this compound potassium oxide. You are welcome to pause the video if you need time to make notes, or go back a little bit if you need to listen again. I'm now going to go to the next example. Our third example, I'm going to use magnesium fluoride. Magnesium is in group 2. It's got 2 valence electrons. Fluorine is in group 17. It's got 7 valence electrons. Because it's an electropositive element reacting with an electronegative element, magnesium gives its electron to fluorine. Magnesium needs to give both electrons away to be stable. So it requires another fluorine atom to come closer and to take the second electron from the magnesium. So there we have it. The second electron of the magnesium goes to a second fluorine atom. Now the magnesium has lost two charges, two negative charges. So its charge is 2 plus. Fluorine has received 1 electron extra, so its charge will be 1 negative. But there are 2 fluorines, and I'm going to put 2 here. You could put the 2 there to indicate 2 fluorines. Let's rather do that. Then, when we write the formula for magnesium fluoride, you've got 1 magnesium that's joined to 2 fluorides. The fourth example I want us to look at would be, let's go for lithium oxide. So lithium is an element in group 1. It's got 1 valence electron, and oxygen is an element in group 16. It's got 6 valence electrons. Lithium is electropositive and oxygen electronegative. Oxygen needs another lithium so that it will form a stable ion. So another lithium comes and it gives its electron to the oxygen. This is very similar to the second example we did, if it wasn't the same. And lithium, you have 2 lithium ions now, each with a positive charge, and you've got 1 oxygen ion with its 2 negative charges. So the formula for lithium oxide is Li2O. Let's turn the heat up a bit. Example number 5. Let's see what aluminium sulfide will look like. Aluminium, an element in group 13, has 3 valence electrons. Sulfur, an element in group 16, has 6 valence electrons. Aluminium is electropositive, so it will give an electron to sulfur. But sulfur needs 2 electrons, so there we go. The second electron goes to the sulfur atom. Now the sulfur would be happy. It's got 2 electrons. But aluminium needs to give the third electron away. So what happens to that third electron? It calls another sulfur atom closer together to it, and the aluminium would give its electron to the sulfur atom. But the sulfur atom isn't happy with 1 electron. It requires another electron. So it calls another aluminium atom closer together, which then gives one of its electron to the sulfur atom. Sulfur is now happy, but aluminium not. So it calls closer to it another sulfur atom, and aluminium, being the electropositive element, gives 2 of its remaining valence electrons to the sulfur. Now everybody is happy, and we have 2 aluminium atoms that has formed cations with a 3+ charge. And we have 3 sulfur atoms that received 2 electrons each from the metal, and that gave the sulfur atoms a two negative charge. So the formula for aluminium sulfide is Al2S3, aluminium sulfide. Right. We're moving on to metallic bonds now. Metallic bonds are formed when valence electrons are delocalized, and there will still be strong electrostatic forces of attraction between the delocalized electrons and the positive atomic nuclei. So these atoms of the metals are kept in fixed positions by these strong electrostatic forces of attraction. The properties of metallic substances can all be explained using the theory that the valence electrons are delocalized and free to move from atom to atom. They are extremely good conductors of electricity. They are good heat conductors, thermal conductors. They are malleable. They are ductile. Malleable means you can heat them into sheets. Ductile is you can draw them out into wires. They are lustrous, meaning that they are shiny. They are sonorous, meaning that when you hit it with a hammer, it makes a ringing sound. They have high densities because the atoms are closely packed in crystal lattices. They have high melting points because of the strong forces between the atoms. All these properties can be explained using the concept of delocalized electrons that are free to move through the lattice. Right, the last group of elements we just want to discuss quickly is the properties of metalloid substances. Now, metalloids are the elements with both metallic and non-metallic properties. They shine like metals, but they are brittle like non-metals. Their exceptional property is in connection with the conductivity of electricity. Their conductivity increases. They become better conductors of electricity when the temperature increases. Any other element, type of element, the metals, their conductivity will decrease as the temperature increases because the resistance will be increased. We'll discuss this in more detail at in another lesson. Right, I think this brings us to the end of this lesson, and I hope you found it useful. Enjoy the rest of your day.